Question number 1 on your handout says to test if higher octane fuel results in better gas mileage, researchers collected the data below. Each driver randomly received a full tank of each type of gas, and the miles until empty were recorded. Okay. On this handout, I have mixed up the questions from the 2 sections because we have 2 main strategies. It's whether we're doing the mu sub d or the mu1 equals mu2. We did the difference when it was a matched pairs design, when they are dependent, when they are related in some way. We do the 2 separate ones if they are independent. There is no relation between them. So the very first question you have to be able to answer on every problem is to know which type you're doing. Are these independent or dependent?
Dependent.
Dependent. Right. This means it is a matched pairs. Okay, the reason this is a matched pairs, I didn't just go take and say, all right, Cody, you're getting this type of fuel, and Kelson, you're getting this type of fuel, and then I'm going to compare. I gave each of you a full tank of each type of fuel and recorded it. So one person did both different types. So we have one vehicle recording their mileage from each type of fuel. That's why it's a matched pairs. Okay, so your null and alternative. When we are talking about matched pairs, we look at the mean of the difference. So it should be the mu sub d equals 0. I just want to know to test if higher octane fuel results in better gas mileage. Can we agree to do for our difference? Yeah, let's do the 87 octane minus the 92 octane, just L1 minus L2. So if you are subtracting those and we're testing if the higher octane had better mileage, we are recording the number of miles driven. What should be true when you subtract those? So if the higher octane was better mileage, that means the higher octane should be able to drive further. So this one should be larger, so when I subtract them, it should be less than 0. Does that make sense? Okay. The better your mileage, the further you can drive with your gas, right? So if I want to know if this one has better mileage, that means it drives further. So if I'm subtracting them and this one's bigger, you get a negative number.
It's just the order that we did. We did it the opposite way.
Then you would be, yeah. Okay, we're going to test it. So these are pretty much all centered around the calculator, but you do have to be able to write down some things. So go to your calculator, edit. You need to enter your info into your L1 and L2 quickly because time is. So I'm putting my 87 octane into L1 and my 92 into L2. What should you do on this scenario for L3? Okay. When it's a matched pairs, your L3 is L1 minus L2. So you enter that into your heading and it will calculate them for you. Then we have to go to stat tests. Since we're talking about mu, that's a t-test. Since we have the difference, we are just doing the regular t-test. So number 2. Our input is data. What mu are we testing? What list should it be? L3, because we're doing the difference. We are testing less than So what you have to have written down is your T and your P. At the very least. Yes, ma'am.
How many decibels?
I usually do 4. Alright, so our conclusion, you also need that. We've got these. What's my conclusion? If we look, our P, alpha was 0.05. So my P is greater than. What does that mean? Fail to reject. Okay. Part D. I'm asking you for a confidence interval. Your calculator can do this for you. If you go to stat, tests, we only have one sample. Our variable, if we're talking about mu, we need a T interval. So it's number 8, T interval. My input is data, my list is L3. We're doing a 98%, so confidence level 0.98. We get negative 17.49 to 7.3053. So the interpretation, couple ways. You could say because our 0 falls in this interval, that means we would fail to reject the null. You could also say this means we are 98% confident that the difference in the means is between negative 17.49 and 7.3053. And again, since that includes 0, we fail to reject. For the sake of time, because I don't have a lot, I'm not writing that sentence, but you guys can and will be expected to on the test or quiz. Okay. Are we okay with number 1? Let's look at number 2. So engineers conducted an experiment to determine if ramp meters result in faster traveling time. A random sample of 15 cars was collected one day with ramp meters on, and then a different sample was collected another day with the ramp meters off. The speeds were collected, so this table is giving us speeds. Assume the data is normal. Test the hypothesis at the alpha equals 0.1 level significance. So we have to have a null and alternative. The question, I didn't ask you to state it this time, but we need to know. Is this a matched pairs or not? I collected 15 cars, on versus off, but did I do the same 15 cars? No. I went out there one day and watched the first 15 cars that went by, and then I went out there a different day and watched the first 15 cars. So is it an actual matched pairs? No, those are 2 separate samples. So this will be the mu1 equals mu2. Or you could, if you want, you could do like mu on equals off. If that helps you, you could call 1 and 2. I don't really care. We are testing the hypothesis if the ramp meters result in faster traveling time. So if it's faster, your speed is higher. So the on should be greater than the off. Okay. So we go to edit, you're going to clear out everything that's in there and enter these data points. The L1 will be my on and L2 will be my off. And I collected data from 18 cars, not 15, just so you know.
Yes, I noticed like there's 2 rows of videos.
Yeah, I think I just said that twice, but we're just going to roll with it. Okay, so now, when we go to stat tests, we're talking about mu, so it's a t-test. Do we have 1 or 2 samples? 2. So you are going to go to the 2 sample t-test, number 4. We're basing it off the data. List 1 should say L1, list 2 should be L2. Frequencies at 1, we are testing greater than. Pooled is no. Calculate. And I expect you to write down your T and your P. T is 1.8. What'd you guys get? Thank you for being so precise. And our P is 0.039. Okay. So, now what do we have to do? Alright. How do you know if you reject? So my alpha this time was 0.1. My P is smaller, so we would reject the null hypothesis. So in terms of that, what that means is the ramp meter did make our traffic faster. Okay. Number 3. To test the belief that sons are taller than fathers, a student collects data from 13 fathers with adult sons. Assuming the data is normal, test the claim at the alpha equals 0.1 level. So, first question, which type is this? Is it matched pairs or is it not? Why is it? So why would we say it's matched pairs?
Because it's 13 fathers with their sons.
Right, it's not just a random 13 sons and a random 13 fathers. They are a pair. We took a father and his son. So they are a pair, they are related. Does that make sense?
Okay, but like, isn't that technically unfair? Because like, as you get older, you do shrink.
So maybe there are other things to take into consideration.
Like, you
Should
should
that
have.
not start happening until you're like...
I mean, if you're an adult son, like you have an adult son, like you're probably like in your 50s or 60s.
So if it's a matched pairs, we do the difference equals 0. And we want to see if what is true. Okay, so if we make our difference father minus son, L1 minus L2, then if the son is taller, it would be less than 0. Okay, enter your stuff into L1 and L2. Because we are doing the difference, what else do you have to do? The L3. Then which test do we go to? If we're doing the difference, we are doing the regular t-test for the data. Mu should be 0, list should be L3, and we are testing less than. I expect you to write down your T and your P. T-test. So this is kind of a big piece. You can do all these by hand if you need to. But if you're doing it on the calculator, you need to make sure you're entering your stuff correctly, because if you're putting it in the calculator, I don't have as much work to look at to give you partial credit. So mistakes are going to count off for more. You have to know which test to do. If you're doing the difference, you're going into your regular t-test for L3. So if I look at this, my P is 0.35, My alpha here was 0.1. P is greater than alpha, so what does that mean? Okay. Alright, let's see if we can get through the last one. We have a couple minutes. Okay, researchers collected the data from 2 different populations. So, is this matched pairs or not? No, I just said 2 different populations, so we're going to assume they are not related. So part A, these are independent. So if they're independent, your null hypothesis is what? Mu1 equals mu2. Alternative is mu1. We are trying to see if they are different. Okay. Part C. I told you it's normal. So, which test do we do? No, that's a confidence interval. It's a 2-sample t-test. Okay, so then we are going to base it off stats. Your x sub 1 is 111. S of the first, 8.6. N is 20. X of the second, 104. Standard deviation, 9.2. N is again 20. We are testing not equal to. Pooled is no. Calculate. So T is 2.4858. P is 0.0175. So my alpha was 0.05. P is smaller than that, so what does that tell me? Reject the null. D wants a 95% confidence interval for the difference in the means. So we go to stat test. We want a 2-sample t interval, so no, 0. Based off your stats, confidence level is 0.95. Pooled, no. What do we get? And because that doesn't include 0, that would also confirm that you need to. Those are yours. You might look back over them. The key thing, guys, you have to know, first of all, is it matched pairs or not? And then you have to know which test you're doing for each scenario.